Okay, so looking to answer that question, sink or float. So where we left off was gravity. So that attractive force between any two objects that have that are made up of matter, that have mass. And so we're just going to take a look at Earth. And the attraction, we'll say some planetary body, right? And the attraction, again, is between the two centers of objects, okay? It's a together force. So if I have an object here, I'm just going to... we have this attractive force here between their two centers. So again, gravity is not a downward force, it's a together force. We really look at it, and each object has a gravitational attraction force to each other. Right? So it is this towards the center force. Right? So it's not downward, right? Because downward would mean something would fall like this. Right, and from where we are, it does appear downward, but it's towards the center of each object. You've heard that, center of gravity, okay? So the factors that affect how strong gravity pull, though we showed in the last clip, had to do with distance. Okay, the closer things are, the stronger the gravitational force, the further they are away. Oh, I can use this right here. I'm trying to use my magnet, it's just really strong. So these two are far away, right? So they're not interacting until they get close enough. And the second thing is that the amount of stuff, the amount of mass. The more mass you have, the stronger the pull, that gravitational force, that attraction between objects. And gravity doesn't work like a magnet. I'm just using magnets to demonstrate that actually works a bit differently, which we'll get into later when we're talking about orbits. And then the more paper clips I put on, the harder, and you can see the further down, the harder I have to pull this. Okay, so this is the same amount of paper clips in that space, which leads us, so that means the gravitational force is pulling harder. Oh, all right. So that leads us to sinking or floating, and then that's based on a property of something called density. Again, how close, how packed in or how close together or spaced out your particles are. So if we looked here, and let's say I have an object here, all right, and we put them water, right? And this one has this many paper clips inside, all right, versus this one here, okay? The gravity of those paper clips, because it has more mass, is pulling stronger on this object, and that object also pulling stronger here on this object. So this is going to have the force, the downward force. Now, if this one is less, okay, than the surroundings also, yep, then the gravity is going to be pulling on these things more, and this less, it's not going to be as strong. So this one would float to the top, while this would go to the bottom. So whether something sinks or floats has to do with its density, how much stuff is packed in that space. And if you are more packed in than your surroundings and you're able to freely move, then you are going to sink down. And if you are more spread out or less packed in than your surroundings, you are going to go up, because gravity is not pulling on you as hard as the surroundings. So whether something sinks or floats has to do with a property called density. Again, how you're more dense if you have more stuff in that space, and then you are less dense if you have less stuff, we could say paper clips, in that space. And so here, this object, the gravitational force would be stronger between these two objects, because this is pulling on this harder and this is less, so that would float to the top. And density, all right, can also be, is a property of an object or thing, but it can also be influenced by temperature. So temperature, changing the temperature of an object can also change, temperature's over here, also change its density. So temperature can change its density because temperature is a measurement of how fast molecules are moving, so the speed of molecule movement. So the faster, the warmer something is, the faster the molecules, we'll say the marbles are molecules, moving, the faster, the more they hit each other and the more they spread apart. All right, so there's more space between them. All right, so they're going to be less dense. So as we increase the temperature, all right, we are going to decrease the density because they're spreading out. When things are colder, they're moving slower, all right, and for the most part, with some exceptions, these things get closer together because they're not hitting each other as hard, and then they become more dense. All right, so what we have is temperature affecting density. When something becomes hotter, all right, it becomes less dense. Oh, less. Because things are more spread out, because they're hitting each other faster. And when things are colder, they're going to be typically, except for some exceptions like water, they will become more dense and they will sink. Hotter, spread out, colder, moving slower, and they are going to be closer together.